y'all. Today we're going to be talking about implicit differentiation. Implicit differentiation has to do with functions that have been defined implicitly. So before we can kind of get that, let's talk about the difference between an explicit form of a function and an implicit form. So the explicit is when the variable y is explicitly written as a function of x, which just means y is by itself. So our explicitly written function would be like y is equal to 2x plus 3. Okay, something nice and simple. Y is by itself. It makes a lot of sense. The implicit form of a function is the variable y is not explicitly written as a function of x, which means it's not solved for itself. It's not by itself. So that's something more like this. 2xy plus y squared equals 5. Okay, we got x's, we got y's. Y is not by itself. It's kind of this old mixed up function. That's what we mean when we say an implicit function. Okay. Now, when we have it implicitly, obviously, if I could, I would just solve it for y real quick and then make it a much easier derivative. But if I can't solve it for y, then we have to use implicit differentiation for us to be able to find that derivative. So let's look at some examples. So if I wanted to derive x cubed, so I'm finding the d dx of x cubed. Well, we haven't really talked about this before, but isn't x technically its own function? Yes. Okay. So I'm just going to it's going to seem like a little bit of overkill, but I'm going to treat this like x is a function and the cubed is a function. So this is kind of like chain rule, yeah? So if I was doing this the chain rule, my 3 would come down, parentheses, x would stay the same in the inside, reduce the power by 1. And then what is the derivative of x? Well, the derivative of x is 1. So times 1 d dx. Okay, now you might be like, Mr. Abone, we've never written this d dx term before. You're correct, because technically we've been very, very lazy up until this point. We have not been writing that d dx. d dx just means the derivative with respect to x. Now, d dx is just equal to 1. So when I get that d dx term, it really just goes away. 1 times 1 is 1. So our derivative is just 3x squared. Okay, because I took the derivative of x with respect to x, which is kind of like dx over dx. So it just becomes 1. Okay, so hopefully that should have been pretty straightforward. I know the chain rule part was weird, but it's mostly just to help with our next one. So over here, we have the d dx of y cubed, okay? Well, y is definitely a function. I mean, it's a y equals equation, something like that. So we're going to treat this like a chain rule. So same idea. 3 comes down, parentheses, power reduces by 1. Y stays the same on the inside, and then I multiply by the derivative of y. So 1 dy dx. Okay, now what's a little bit different about this? Okay, our other one was dx dx, which just became 1. dy over dx does not become 1. dy and dx are 2 different terms. In fact, what is dy over dx equal to? Well, dy over dx is equal to the derivative. So this would be equal to 3y squared dy over dx. Okay, now I couldn't really call this a final derivative because, well, for one, I don't really have an equation. I don't have an other side of the equation, so I can't really get to the other side. What is this equal to? Okay, but what I just want you to see is that with implicit differentiation, when we derive x, we get that dx dx term, which just becomes 1. When we derive y, we get the dy over dx term, which does not go away because dy over dx is equal to the derivative. Let's look at another one. So number 3, we have d dx of x plus 3y. So I'm just going to kind of jump ahead. So the derivative of x is 1 dx dx plus the derivative of 3y. 3 stays the same. Y is just 1. and then dy over dx. So just simplifying a bit, dx over dx is 1. 3 times 1 is 3. So this would be equal to 1 plus 3 dy dx. Okay, so notice x term I derived like normal, y term I derived like normal, but I had to multiply by that extra dy over dx term. So you should start to notice a theme. X terms are going to be fine, y terms are going to become dy over dx. Okay, our last one, we have ddx of x times y squared. Okay, so this one's a little bit different because what do we have happening in between? We have multiplication, and x and y squared are both functions, so I have to apply the product rule. So here, the derivative of x is 1 dx dx. The derivative of y squared is 2y dy dx. And then just like normal, I'm going to cross multiply. So this is equal to x times 2y dy dx is 2xy dy dx. Y squared times 1 dx dx, which is just 1, is just equal to y squared. So the weirdest thing about implicit differentiation with the product rule is that because we only have dy dx in the derivative of the y function, we don't end up with the dy dx on both terms that involve y's, which is weird to think about, but it's just how it happens with the cross multiplication. Okay. So guidelines for implicit differentiation. So if you notice, all of these, we didn't have two sides of an equation. We were just kind of practicing that skill of deriving implicitly. But now we would have something a little bit more like these over here, where we have a left and a right side to the equation. So just like we had with our implicit function up here. Okay. So what I want to do is I want to differentiate both sides of the equation with respect to x, the same thing I was just doing here, 1 through 4. Any of the terms that have y in them are going to get that dy dx. Any of the terms with x in them are going to get that dx dx, but it's just going to be equal to 1. Okay, so let's start by doing that over on number 5. So derivative of x cubed would be 3x squared 3x squared dx dx plus 4y cubed dy dx, because it's a y term, minus 2y squared dy dx equals, and 9 is just a constant, it doesn't have x or y, so it just becomes 0. Okay, then I can write this again, because dx dx is just 1, so 3x squared plus 4y cubed dy over dx minus 2y squared dy over dx equals 0. Okay, so I've done my first part. I've derived everything. Second step, I want to collect all terms involving dy dx on the left side of the equation and move all other terms to the right side of the equation. So I want to leave all of my dy over dx's on one side, move everything without dy over dx to the other side. So this stays 4y cubed dy over dx minus 2y squared dy over dx. And to move that 3x squared, I'd have to subtract it. So negative 3x squared. Okay. Next step is to collect all terms involving dy over dx. Just did that. Next step is to factor dy over dx out of the left side of the equation. So what you notice is because we have everything on the left side has that dy over dx in it, I can factor it out like it's a greatest common factor. Okay, so I can take out dy over dx and multiply it by 4y cubed minus 2y squared. And that would be equal to negative 3x squared. Okay, so now I have dy dx by itself outside the parentheses, which means the last thing I'm going to do is I'm going to solve for dy over dx by dividing over what I have left. So solving for dy over dx, I'm just going to divide this whole piece that's being multiplied over to the other side. So we get dy over dx equals negative 3x squared over 4y cubed minus 2y squared. So we get this big whole mess, and it is a bit of a mess, as our answer on 5. Okay, so just to run down the steps again, derive everything. X terms get dx, y terms get dy over dx. Then move all non-dy dx terms to the right side. Keep all dy dx terms on the left side. Factor out that dy over dx. Divide over what you have left. Okay, I'm going to let you all go ahead and try 6 on your own. All right, so this is what you should have gotten. Hopefully pretty similar to number 5. Deriving all the y terms, get dy dx. The one x term, we just get the dx dx, which is just 1. Constant goes to 0. Move 2x over. Factor dy dx out of everything. Divide over what's left. All right, let's look at 7. So 7's a little bit harder because we have that x squared y, so that's another product rule. So this time when we derive it, we're going to have to apply the product rule for that term. So derivative of x squared is 2x, and I'm not going to keep writing dx dx. We already know it becomes 1. Derivative of y is 1 dy over dx. Then we can cross multiply. So x squared times dy dx, 2x times y, then plus 3, x goes away, and 25 just becomes 0. So note, just like we did before on number 4, with that cross multiplication, the dy dx term ended up with the x, not with the y. So that's what's really weird about product rule. Don't freak out. That's by design. That's how it works. Okay. But now we can just finish out by moving everything non-dy dx to the other side. So that gives us non-dy dx. So that gives us x squared dy over dx is equal to negative 3 minus 2xy. Okay, we don't even have to factor out dy over dx because we only have one term left. So that gives me dy over dx is equal to negative 3 minus 2xy, all divided by x squared. So even though it's kind of a weird one because it's the product rule, it was a little bit of a shorter work. Okay. Number 8, another kind of weird one. Okay. So we have x times tan of 3y. So not only do we have product rule because we have x times a y function. Okay. We also have a chain rule in one of them, that tan of 3y. Okay. So let's kind of work through it. So derivative of each piece. So derivative of x is just 1. Derivative of tan of 3y. Derivative of the outside, so secant squared. Inside stays the same, 3y. And then times the derivative of the inside, so derivative of 3y is 3 dy over dx. Okay, then I need to cross multiply. So x times all that, so 3 x secant squared of 3y dy over dx plus 1 times tan of 3y. So just plus tan of 3y. Then minus 5 is just equal to 0. 9x becomes just 9 dx dx, so just 9. Okay? So I got this whole mess over here, but that's okay. I can have a mess. Messes aren't a big deal. Okay, so the only thing I need to move over is that tan of 3y. So we get 3x secant squared of 3y is equal to dy dx is equal to 9 minus tan of 3y. And then last but not least, I can divide over all of this being multiplied with dy over dx. So dy dx is equal to 9 minus tan of 3y, all divided by 3x secant squared of 3y. All right. So a weird one with our trig, but same basic steps, just a little bit of a different derivative rule to take our derivative in the first part. Okay. The last thing we're going to talk about is this d squared y over dx squared. So find d squared y over dx squared. Any guesses on that? I'm hoping, racking your brain around, it probably looks like, dy over dx is the first derivative, so squared, maybe it's the second derivative, and it is the second derivative. So what we're going to do is we're going to derive this twice. The problem is when we derive it twice, we do run into a little bit of a conundrum with implicit, but we'll talk about that here in a bit. So let's find our first derivative first. So same exact steps. So x squared becomes 2x minus y squared becomes 2y dy dx equals 0. Move over the 2x, so negative 2y dy dx is equal to negative 2x. Then divide over the negative 2y, so dy over dx is equal to x over y, because the negative and the 2 would cancel out. And that is our answer for the first part. Okay, now I want to find my second derivative. I find my second derivative by just deriving the first derivative. So when I derive dy over dx, you can see kind of where this d squared y over dx squared term comes from, because d times dy would be d squared y, dx times dx would be dx squared. So it's just kind of shorthand to represent that same idea. Okay, just know when you see it, that means the second derivative. Okay, so d squared y over dx squared is equal to, and what kind of derivative is this? Well, it's a chain rule, or sorry, not a chain rule, a quotient rule. So derivative of x would just be 1. Derivative of y is dy over dx. And then I am still going to cross multiply. So low times derivative of high, so y, minus high times derivative of low, so minus x dy dx, all over low squared, so y squared. All right, and you might think, well, that looks good to me, Mr. Arbone, not too hard. Okay, but I have one unfortunate thing I do still have to deal with, and that is that dy over dx term. So it doesn't really make much sense to define my second derivative in the terms of my first derivative. Like I have multiple derivatives. I'd have to plug into multiple functions if I wanted to try and solve this out. It's kind of a mess. So the last thing we need to do is we just need to take this dy over dx, what we know to be dy over dx, and we're going to plug it in right here for that dy over dx. And that's our last step. We just got to replace the original derivative. So d squared y over dx squared is equal to y minus x times x over y all over y squared. And you can simplify from there if you wanted to, or we can just leave it like that. Okay, and that is implicit differentiation.